Yes.
Nice. All right. So today we're going to be talking about a different type of relationship. Yesterday we went over the one-to-many, and so naturally the next level to that would be many-to-many. We alluded to it a little bit when we were talking about books and authors, where we kind of have to like make believe and pretend where um, an author can write many books, but then for whatever reason, each one of these books can only have one author. So going to the next level, in reality, we talked about textbooks that sometimes you'll see 4 or 5 different authors on a particular textbook. And so the idea is that sometimes, right, an author can have many books and a book can have many authors, right? So what we want to talk about is like demonstrating the single source of truth when we're talking about this many-to-many relationship, because we talked a little bit about it when we did the one-to-many. And then now we're actually going to talk about the single source of truth as it relates to a relationship where there's many-to-many. So we kind of talk about books and authors, and here's just some examples of like a many-to-many. Sometimes like class like, doesn't really get it until they see a bunch of examples, but like projects can have many backers. So like let's just say you're trying to become like this next startup unicorn, and you're like, hey, listen, please give me money to start my business. Do you want your money coming from like necessarily just like one person, or is it kind of going to be like, all right, you know what, your idea is kind of cool, I'm going to give you 100,000, and then you want to go to somebody else and like, cool, you're going to get another like 50,000 from me, and then you go ask your brother and it's like, dog, I really believe in you, here's 50 bucks, it's all my money. And so you have many backers, right? You have many people that want to fund you. But then all of these like VCs, right, these venture capitalists, they can in fact invest in many different projects or many different people. And so that's like another many-to-many. If you want to be like a total bro like me, right, the idea is that at some point you'd go to the gym, right? And a gym can have many like lifters or like many people that go to the gym goers, so to speak. Yeah, and then each one of these like gym members belonged to a gym, right? Like I would get up, I'd be like, oh, let me go to my New York Slums Club, let me go do chess today, whatever it is. And then that New York Sports Club says, like, hey, I have a lot of lifters, and each one of these lifters belongs to the New York Sports Club. Yes? No? It's not. It's a one-to-many, right? And then ClassPass happened, where it's like, you know, ever heard of ClassPass? The idea is that I can just pay this one subscription fee and join a bunch of different gyms. So the idea is that in the one-to-many version of this, I can go to Health and Racket Club, I can go to New York Sports Club, I go to Equinox, I can go to Crunch. I can belong to many gyms, and all these gyms, again, would have many members. So when you really break down this many-to-many, right, when you break down this many-to-many, like, let's be real, you break down the many-to-many, it just sounds like a one-to-many and a one-to-many, like, combined. So let's think this through, right? You have like authors and books. That's a terrible one. Let's not use that one. Like parents, for whatever reason. This is a pretty decent one. Like parents can have a lot of children. And then children, how many parents can children have? Biologically, 2, I guess, so to speak. But in theory, you could have like many different parents, right? Godparents count as parents. Step-parents, right? You can have like many different parents. We're not trying to get into like genealogy here, but this is just sort of like this relationship. Some example like these city bikes over here. You guys pass them like all the time, right? Like a city bike can have many different riders, and many different riders can ride many different city bikes, right? Like you don't have your name on one of these bikes and that's yours forever, because if that was the case, then you just bought a bike, right? All right, cool. What about like sports? Right, a baller can play many like basketball games, and each one of these basketball games has like multiple players in them. Cool? So far so good? Nothing crazy? All right, so this one's really silly. I like this one. Let's just set this up real quick. I'm gonna paint you a little picture. So stupid. So let's just say you're a squirrel, right? Or there's like a squirrel in general, right? A squirrel makes this little home inside of a tree, right? And trees have like millions of branches, but that's not really important. This one tree, do you think this one particular squirrel takes complete ownership of this one tree, or would you say that maybe this one tree can be home to many squirrels? Many squirrels, right? So how would you describe that relationship between a squirrel and a tree? Squirrel to a tree is 1-to-1? Well, think about it, right? Like every year, right? So squirrels are like interesting creatures, right?
They're amazing creatures.
Oh, thank you. I mean, I'm not a squirrel.
They're
But,
amazing.
but the idea is that like this squirrel can make a nest in like an oak tree, and then like a couple seasons later, it gets cut down or whatever. It moves, moves out of the nest, and it goes to like this maple tree down the block, and then it goes down to like an evergreen or a redwood. I know a lot about trees for some reason, right? But the idea is that this squirrel can live in many trees, right? Or like have a bunch of nests, whatever, and then each of these trees can house many different squirrels. So this is like a sort of like a many-to-many relationship, right? If that makes any sense. So far, so good? In the matter of squirrels, yes, there's a many-to-many relationship between squirrels and trees. But let's think, right? Like, even if you were like thinking about like a park, there's probably like dozens or hundreds of trees in there. If I'm a squirrel, right, how do I know and identify each one of these like trees? Like, do I care about every single one of these trees in this park or forest? Not really. Just the ones that I like built a little home in, right? Like a nest. I have like a nest in this tree. And so the idea here is that now we have this new model in here about this nest. So we have a squirrel, and we have a nest, and we have a tree. Cool? So the relationship between this squirrel and this nest, how would you describe it? No big deal. No biggie. Just saying. Right, because like if I make a particular nest in a tree, that's my nest, and I will defend it to the death. And how many nests can I make, though? I can make a lot, right? So if I were to just completely finish this relationship, let's actually do this here. Right next to our good friend, users and tweets, right? Let's do this. I have a squirrel here. Boop, boop, boop. S is for squirrel. And I have, let's do that. No, that's not going to be good. Let's just start over. So I need a lot of space. Let's just start over. I have this squirrel here, right? Sorry. And then like I have this tree here. Cool? This tree. Actually, I'm going to try drawing it. Bloop, 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 bloop. Yo, I'm on the touchpad. Wow. Powerful. All right, guys, I'm quitting the artist life for me. So the squirrel, I'm not going to draw the squirrel. I'm not going to do that because I suck. So squirrel it. Huh? What? Oh, you're right. What I mean to say is I just need to cultivate my skills a little bit more. I'm a beginner. I'm a student.
You're a beginning artist.
Student for life. All right, so what's this relationship between this squirrel and this tree? Many to many, right? So we're just going to draw all these like cool many lines. Boop, 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 boop. Yep. Cool. Right? Oh my God. But the idea here is that the squirrel only knows about the tree through what? Through this nest, which is interesting. So I'm just going to put this nest here. So like, where does this kind of fit in? Well, we talked about the relationship between the squirrel and the nest, and what was that?
Yeah, one nest to many squirrels.
One to many with the squirrel and the nest, right? And that is the squirrel can have many nests, but this one nest, actually let's do this. The squirrel has many nests, boop, boop, boop. But the nest belongs to the squirrel. It's like this one-way relationship. What about the relationship between the nest and the tree? What is this like?
One tree has one nest.
Yes, but I'm talking about the particular nest, right? Think about the nest as like a class. Every time I make an instance of it, right, what is the relationship between the instance and sort of like this class, right? So this one nest was built by the squirrel. What would you describe it as? This nest and this tree. Is it many to many?
Many to one. Because if you initialize a nest class, it would have one tree. Or it would have
Right. The one nest, this one nest can belong to how many trees?
one tree.
Just one. But a tree can have how many nests or nests? So I'd say this tree and this nest is more like a one-to-many relationship. Right? This is kind of ugly, so let's draw this out again because this is how it looks at first, right? You're trying to figure out what is known as like your domain. You're trying to figure out the domain model. You're just kind of drawing a bunch of lines. Like, I'm trying to establish these relationships. Eventually, you think through it and you figure it out, and then you're like, cool, let's make this a little bit cleaner. So, actually, let's go so far so that's like insignificant. Let's do this. Doop, doop, doop. Boop, 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 boop. We have squirrel, and we have tree. And we know that this is many to many. And then we have nest here. Nest, right? It just looks like this. I'm assuming that's what a squirrel's nest looks like, right? Maybe there's some eggs in there. Oh, they don't lay eggs? I know a lot about squirrels. Oh my God, you're right. They are mammals. These are baby squirrels. They're just in the infancy, and I'm drawing on a whiteboard app. So the relationship between squirrel and nest and tree and nest is what? One more time. Squirrel and nest. Squirrel can have what nest? Many. And then tree can have what nest? So what you're really seeing here is whenever I have this many to many relationship, there has to be some sort of join that connects this squirrel to the tree or this many to many relationship. And what I mean by that is, remember, the squirrel cares about all the trees or only the trees it has what? Particular nest in. So the squirrel will only know the tree through the nest. And that's sort of the idea, right? This example is a little bit contrived, but you can do another one which is a little bit more practical. It's not as fun though. It's not as fun, right? Let's just say instead of becoming smart web developers, what we all decided to do is become doctors, right? So we have doctors, and doctors do what really? Right, they see patients. So we have doctors and we have patients here. Cool? And what's the relationship between doctor and patient? Huh? Right, doctors, right, has many patients, right? They can see many patients. And then a patient has how many doctor or doctors? Like one, two, many, right? I'm going to go see, I was going to say gyno. I don't know why it was the first thing that came to my head. I don't need to see a gyno, but thank you for laughing. That could have been real dicey, right? So the relationship is many to many. But like I just mentioned, in a many to many, there has to be some sort of connector, right? If I were to call your doctor, right? I'm not going to violate HIPAA or whatever. This is a terrible example. I'm thinking about it now. I'm going to call a doctor. I'm going to check on my brother. And I'm going to be like, hey, do you know a Mr. blank blank blank's name? Wayne. And they'll be like, oh my God, yes, I do know this person. I just saw him 2 weeks ago, Tuesday at 3 o'clock. What would you describe that? How does the doctor know this patient? Through this appointment, right? So now we have this new model, A for appointment, in America. So how would you describe this relationship here between doctor and appointment? The doctor goes to work and sees like what? Probably more than one. Like I'm not like $80,000 in debt in medical school, so I can see one patient a day. That'd be crazy. So in theory, the doctor has many appointments, right? Bloop, bloop, bloop. But this appointment, right? What's the relationship between the appointment and the doctor? like this appointment probably belongs to the doctor, right? Like if you're gonna go make an appointment with a doctor, you don't want to go in and see anybody else. You want to see that doctor. So that appointment belongs to the doctor. But what about this patient and appointment? Patient can have what amount of appointment or appointments? One or many? Many, right? This is looking kind of familiar here. And the appointment and the patient, this one appointment, how would you describe this relationship with the appointment and the patient? It belongs to it, right? So let's just take a quick parallel and see. Well, this one's not as sexy. But do we see what's going on here? Whenever you have this many to many, there needs to be what is known as like this sort of like joiner. This like sort of join model, this join. I'm just going to call it a table. That'll make sense later. But there's some sort of join. There's a connector there. And the way the doctor knows the patient is by the appointment. And the patient only knows the doctor by the appointment. Because imagine how many doctor's offices are here, right here in the financial district. If you've never seen this doctor, you never made an appointment, would you know him or her? Absolutely not. In the same example about this squirrel in this tree. There's so many trees out there. The squirrel only cares about the ones that it has nests in. Right? So now that we've kind of have like a little bit better of an idea of this, let's actually write some code, put this in practicality, and like put this to some sort of use. Do you guys want to build patients and doctors?
Honestly, yeah, because it's a lot more straightforward.
Or do you want to build squirrels' nests in trees? It's completely up to you guys, but I don't really have a preference.
Squirrel's nest trees.
Thank God. I was talking in the corner with the staff. I was like, I hope they pick squirrels' nest trees. It's just so much more fun. All right, so here's what we can do. Ready? Boop. I'm in this file. There's nothing in here but the README that I showed you. So how do I make a brand new file? Right? Touch, right? Kind of creepy. I always say that, but I always think like,
Don't think about
it's
users
weird.
too much.
So what models do I have? What files do I need here? Okay. Tree. What else? Man, I'm tired. SQIREL, right? That sounds about right. And then finally, nest. If you put touch, that's the command, and you can give it theoretically like infinite number of arguments separated by a space, and this should make all three at once in one command. So if I hit ls, now I have these three files. Cool? Yeah.
Just in terms of naming policy, do they all have to be singular?
They don't have to be, not in like just pure Ruby land, but the idea is that I'll be making a tree class, not a trees class. And so I'm just want to follow that convention. Yep. All right, cool. Let's go back to the code base. And here I am, rocky like a hurricane. I see nest, squirrel, and tree. So let's think about what's going on, right? In terms of this nest file, what do you think should be in it, knowing what we know about this one-to-many relationship? What has to be in this nest class as like attributes? What does the nest really need to know about? Right, this nest needs to know about, whoa, that was kind of cool. This nest needs to know about at least what two things? The squirrel and the tree, right? So should I build this nest class first without even having built the squirrel or the tree class? Probably not, right? But what about this squirrel and tree? Does it really matter which one I start with? Does it? It's kind of not really relevant at this moment. But I'm curious, why would you say that a squirrel or a tree has like a higher importance in terms of like just building out the class first?
I would say the squirrels, because I think that would be the one that would be getting the most use out of and getting off that.
Fair.
Again, it could be wrong coded on that.
No, we'll probably use the squirrel class a lot, right, to be fair. So this might be like where you want to build it first. But in terms of like absolute priority, in terms of what makes sense to build first, the squirrel and the tree class, it kind of doesn't really matter. But the only thing is like try and build the nest class, this join table first, without having the many to many first kind of doesn't really make too much sense. You know, it'd kind of be like in terms of like the child without the parents. All right, so let's build this squirrel. First thing I want to do is require pride because I'm a dirtbag. And I mean to say I'm a very happy, very positive person, and I make happy little mistakes like Bob Ross, and we can just patch those right up. Cool? So how do I build this squirrel class? Very good. Ooh, wow. Thank you. Autocomplete. That was money. Cool. So what do I need here? Right. And what are the arguments, right? What are the attributes of squirrel? Size? For me, I'm very ignorant. I thought they laid eggs for like 2 seconds, right? But for me, this is probably me being very like, not racist. Not a race. They're all like the same to me. They all look exactly the same. It'd be hard to be like, oh, it's a small squirrel or it's a large one.
Squirrels are just wrapped in PR.
What? You know what? Let's just skip that. Let's go with name. I think size is okay, but I don't find much. Okay. Sure. That's going to get dicey, but we'll just go with color. Anyway, I feel like I might regret that. Let's go with name and color for now. No big deal. Yeah. Do I want to do nest first? No. I'm actually saying the opposite, and that is like the nest. Remember, is the join between the squirrel and the tree. So the squirrel or the tree has to exist, sort of like before this nest should exist. So in terms of, yeah. So in terms of like building them out, I probably want to build either the squirrel or the tree first. But very good. Thank you for clarifying. I'm sorry if I'd like, in my rambling nonsense, like confused you. All right, cool. Because I don't want this to like drag on too much, the idea here is we would probably want to test at this point, right? I'm going to open IRB, run the squirrel file, hit the binding just to see if the squirrel exists, probably create one, and then be like, okay, great, everything works, right? Remember, very, very, very systematic approach. It's like you write some code, then you test it. You write some code, then you test it. Yeah. So if I were to hit the pride, the first thing I would do is create the squirrel, and then I would test the attributes. And it would come back as what? If I were to do this squirrel1 equals squirrel.new, and I were to ask for squirrel1.name, what would I get back? I get some like no method error because I don't have the getter and setter methods. So it's important that you constantly test. And if you're worried about like the code challenge, you're worried about anything, if you test your code systematically every step of the way, you will realize, oh my God, I totally forgot this. Let me go write that code in now. And that's what's really important. It's not about memorizing what this class syntax looks like and then always going, man, I cannot forget to write the adder accessor or it will break and then freak out. They're like, oh my God, I didn't write this code. But if you test every step of the way, you'll be like, oh, I forgot this, and then you'll add it. So that should hopefully put you at ease a little bit, but the idea is you should be testing every step of the way. Cool? All right, so let's do that. The adder, reader, writer, or accessor for name and color.
You should probably have a reader.
What was that? I probably put both, right? They're not like chameleons, right? They're just one color. Unless like a human being comes by and like spray paints them, that's kind of wrong. But we're not going to get into that. We're not going to get into that at all. And or whether or not I've ever done it, I haven't. See you judging eyes over here. All right, so cool. We have this squirrel class. It looks good to go, right? Nothing too much crazy about it. Let's build this tree class. Boop, boop, boop. All right, we'll change that to tree. And then what attributes do you want for tree? Species? Let's put type because I'm lazy. And that is dicey to spell, right? Like I before C, except after E. And you're just like, what does that mean? Cool. Anything else about this tree? We can leave color if you want. Size. Sure. Trees have different sizes, right? Not like squirrels. All right, cool. We can test this as well, right? So let's actually do that. Ruby tree.rb. So should I have access to squirrel here? In this tree class, do I have access to squirrel inside this tree class? No, right? So what should I get here? Cool. That should make sense, right? Like this shouldn't be scary when you get into these errors. You should think through why something is happening, and so you can back trace why something would happen. Cool. But do I have access to tree? For sure. So I can do tree dot. Oops. Let's do that. Tree 1. Wow. It's the army in me. That's how we say 3. It's tree. It's silly. Tree.new. And what are the attributes? Oak and large. Very good. Large and in charge. Cool. So can I see the size of this thing? Oops. Yeah? Cool. What did I put in there? The reader? I put just a reader in here. Cool. And what about the type? Interesting. Can tree sizes ever change? Probably. So we should probably do what? Dang. There's no like sexy shortcut for that? Yeah, RW tab. Read write. Let's see it. Ready? RW. Wow. Brianna shortcut queen over there. Powerful. All right. Oops. Let's do that too. That had been confusing to some people. All right, good to go. All right, so now we've got this tree and we've got the squirrel, and we have the 2 models that we need within our domain. And now it makes sense to sort of build this nest, right? And then we can start establishing methods, class methods, instance methods, and then build out the relationship between them. So, any questions before I move on to nest, right? Squirrel and tree, pretty cool, pretty cash, MBD, just review. All right, let's do nest. Bloop, bloop, bloop. Oh, this. Okay. Nest. Eat. All right. What are the attributes of this nest? What important things do we have in this nest? Right. It has to have some sort of squirrel. And it has to have some sort of tree in it. For right now, are there any additional attributes of this nest that are important? Huh. Is it? Yeah, I heard you. I was impressed by it. Yeah, sure. Yeah, God. Sure. Sure, let's do that. Cool. So sometimes, like this join table, may have additional information besides just the models that it joins. So for example, in this doctor and this patient example, we had the appointment as like that join table, that join model. What information about the appointment besides the doctor and the patient might the appointment model need? Who said date? Somebody said date, right? The day, the time. And so don't think of this join as like simply just holding the model. Sometimes it'll hold additional information. Cool? All right. Cool. So the next thing we need is like, in order to kind of establish these relationships, it's a good idea to at least keep track of all of them that exist. So far we haven't built any methods whatsoever. So let's kind of start with this like all method that I think is kind of useful just in general. So how would I do this all again? What kind of variable should you be using? This like instance variable like here, all, y class. Yeah. And then I'm gonna just simply push in, push in like the self. Every single time I make a brand new squirrel, I'm gonna put it into this like all array. Cool. And do I have access Do I have a getter method for this class method right now?
Yes.
I said something silly? Okay. Do I have a getter method for the add at all? All right, cool. So let's build it super fast. Boop, boop, boop. Cool. And it's simply just going to return and get the class variable. All right. Cool, cool, cool. Actually, let's do it for all of them. Boop, boop, boop. Boop. Boop, boop. Shoop. Shoop, shoop. Shoop, baby, shoop. Awesome. Awesome. Cool. Let's actually test that, right? I don't want to get too crazy here. I wrote a lot of code. If I make some new trees, let's just make a bunch of these trees. If I do tree.all, huh?
You didn't add the tree.
In the event.
Saw that? Cool. All right. Who feels comfortable being able to like catch that error as you're like copying and pasting, you're moving it? Cool?
That's why I don't touch it.
All right. I did that because I wanted to see if you guys were like, oh my God, it didn't work, and then like freak out. But yeah, oh my God, so powerful. All right, let's go. Let's move on.
You took me same vendor in
I didn't do it in Nest either. I'm a dirtbag. Good shout.
Now you're a beginner.
Thank you. Always be a beginner. Cool. All right, so here, check it out, right? So the idea here is that the first thing I want to do is sort of like establish these relationships. Yesterday we had author be able to write a book. Squirrels probably need to do what? Very similarly. Right? Like build that nest. Good answer. Good answer. I don't know why, but I was like, caught some Wheel of Fortune the other day. I don't know why. And what does build nest do? Makes a brand new nest. Cool. So why is it that I'm writing nest.new and yet I'm in the squirrel class and I know I actually don't have access to the nest class? What can I do? With the drunken sailor. Require relative? Should I require relative tree and nest in here, and then require relative tree and squirrel and nest, and then require relative squirrel and nest in tree? That sounds like a lot for no reason. What's a better way, TM?
the nest class, you could require tree and squirrel.
I could do that. I can have the nest class require tree and squirrel, but then that would mean that the nest class would be doing like all the work. And so one of the things in terms of like programming is, as you keep your files separate, you want them to only do like one thing, right? The squirrel file should just be the squirrel class and have all the squirrel methods, all the squirrel class methods, squirrel instance methods, squirrel attributes, everything about the squirrel in the squirrel file in the squirrel class. Same with the nest. So what can I do? Yeah, I can make a completely separate file that pulls in all three, so I'm not muddying the waters of the other classes. Cool? Yeah, so let's do that. I can either do this, because I'm a dirtbag, and put, what is it, A? Yep. Enter the path. And is it just combo? Nice. I just called it combo because I feel hyped up on Red Bull right now, but it could be anything you want, right? Like run.rb like we did last time. All right, so let's do it. I can require relative. And what is require relative looking for? The file that is relative to where this is. So if that doesn't really make sense to you, let's actually go into an example. The dot, as we talked about yesterday, is like the current folder. And we know that the nest file is in the same folder as combo. So I'm in the same folder, and I'm looking for a file called nest.rb. If, however, and you'll see this, something like tools, and I have a folder called tools. If I moved my combo file into tools, so now we see that the combo is inside this tools folder, right? If I collapse the tools folder, you'll see that combo goes away. No big deal. Now, inside combo, what is the relative path to nest if I'm trying to pull in nest now? Is it in the same folder? No. Because nest, the same folder as nest would be anything in tools. And I don't want that. I actually want to go where? Right, from tools, right, the tools folder, I want to go one more level up. And so I can just go, poop, one more level up. There's a file called nest in there. And so that's sort of this requal relative and like how that path works.
In the case that they're in the same folder, can you omit the first dot?
You can omit the first dot. I just tried using that to like explain what's happening. A good question. All right, who feels a little bit better about require relative? Or I just felt great already, and that wasn't helpful at all. Either one of those is fine, as long as you don't feel bad or worse. It's like two people raise their hands, so I'm assuming bad or worse.
Should it be combo slash nest? Or two, oh, sorry, two. Where is it?
Okay, so here's the thing. Remember, combo is inside the tools folder.
Okay, sorry.
So I'm pulling nest in. So relative to the combo folder, the combo file, which is in tools,
Oh, okay, sorry.
dot would be inside tools, double dot would put me in one-to-many, and in one-to-many there's a nest file. If I was in nest and I wanted to pull in the combo file, I would be require relative. And then where's the combo file relative to nest? It'd be in this folder. There's a folder called tools, and then there's a combo file in there. Yeah?
So you have to go up and down.
Technically, it's just like the current folder. So like nest, right? Inside nest is under what folder?
No, yeah, no,
Oh, okay. Yeah. Inside nest, it's under many to many.
Right.
So if I wanted to get to combo, I'd have to go into tools, then hit combo. The dot just means like current directory. Yeah. Cool? All right, so let's move on from there. Boop, boop, boop. Let's get rid of this. Bloop. All right, and so I'm going to go doop doop, a little nest, a little squirrel action, and then finally a little tree action. And then here, I'm actually going to do my binding. I can leave this one. This combo file is a really good place to make all of my testing data because I have access to all the classes, and it's like its own sort of like testing environment. All I have to do is be able to hit the binding. And hitting the binding is pretty easy. All I have to do is actually run that combo file. So I'll run Ruby, but if I were to type combo right here, would that work? No, it's inside the tools folder. And then I'll hit it. So I see tree. What the?
No, you left the binding in the other folder.
Oh, did I? Oh, yeah, I left the binding here. Bloop. Did I leave in anything else? I did. Embarrassing. 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 I have a friend from Glasgow, and that's how she says it. She says, oh, embarrassing. Embarrassing. All right. Let's do that one more time. I have tree, squirrel, and I have nest. Cool? And so even though I'm writing this nest class here, at some point I'm going to be having them have this shared functionality. So when I actually invoke or execute or proc this method, and it tries to run the nest class, it should work. Does that make sense? All right, cool. So back to this, right? Nest.new. How does nest.new work? Let's take a look at the nest file. It's squirrel, tree, and a Boolean about whether or not it's waterproof. So how do I do this? Right. In theory, right, just like with that book that the author can write, I already know who the squirrel is that is essentially going to be making this nest, right? So who is the squirrel that's making this nest? Me, myself, and I, right? Self. So what are the other arguments I need here? I need whatever tree and I need to know whether or not it's waterproof. And so where are these kind of coming from? Remember, it's going to be some sort of like squirrel1 object dot build nest. And then I can pass in the arguments at this point. So I can pass in a tree like tree1, whatever tree object it is, and then false because apparently this squirrel1's a bozo and didn't think about waterproofing his or her home. Cool. So how do I actually make it so that build nest takes in these two arguments? Well, in the build nest method, I have to say that it's going to receive two arguments, right? The tree and whether or not it is waterproof. Cool? What's up?
So you don't have to call self on 925 when you're creating this growth?
No, because I'm hard coding self as the first argument. So it will always call self. Would it even work? That's such a good question. There's only one way to find out. We got to test, right? So let's do this. Bloop. Bloop. Let's get out of here so I can reload all that code that I just wrote. And I'm going to say S1 because I'm super lazy. I'm not feeling it today, Mr. Krabs. That's a really bad SpongeBob reference. I don't know if you guys actually got the reference or you're just like laughing at me, quoting SpongeBob. What does a squirrel need? A name and name. Oh man. All right, Princess Acorn. Very nice. And what color is Princess? Thank you. Yeah, I know that one's not dicey, right? Oh, you're right. Ooh. Cool. Great. Cool. So the idea here is that I should be able to call this instance method of build nest on the instance of squirrel, which is S1. So S1 dot build nest is looking for how many arguments? All right, and what are they? It's a tree object and it's waterproof, right? Oh no, I need a tree object. Got you, fam. So what does a tree object need? Just type in size, right? So what type of tree do we want to make? Oak? Oh, powerful. Okay. Everyone starts somewhere, I guess. And so now I can do that s1.build nest, passing in the tree object, which is t1. And then what else? Like a Boolean if it's waterproof, right? So let's just say true, because Princess Acorn plans ahead. Huh, look at that. It returns a nest object where the squirrel is here and the tree is here. This right here, this @squirrel, is this a string or is this a squirrel object? So naturally, if I were to do something like, right now, do I have access to this nest? Is it stored and saved in a variable somewhere? No, it's not, right? So how can I possibly take a look at this particular nest? Right? Can I do like n1? Right? I could probably do something like nest.all, which should give me all the nests, which I know how many are there right now. Cool. And I can just take a look at that initial index. And there it is. So now I have a reference to it. Nest.all index 0 gives me that nest object. If it's a nest object, does it have nest methods on it? Yeah. And so we built some methods already on nest, right? The getter and the setter methods. So I can at least take a look at the squirrel. Whoop, it's a daisy. I'm spelled that wrong. It's 2 R's, 1 L. I'm gonna get this right. So this is the squirrel object that I'm now returning. Yeah?
Sorry, can you just repeat why you're passing T1 and true as for that
Oh, okay. T1 is true. Where did I do that? Oh, right here. So remember what build tree needs. It needs a tree object and whether or not it's waterproof. I just said true. Could have been false. This is just our magical fantasy land of squirrels, nests, and trees. Welcome to Mod 1. Cool? Awesome. So,
never answered my question. Could you like say self from the context of outside? Like, you know, if you were calling build nest, we had asked earlier if would that even work, sort of thing. Like if self was a parameter to build nest.
you want to put self in here?
Yeah, I don't think it would work, but I'm curious.
If I write the word self here on line 19, notice how it doesn't change color. This is literally saying the exact same thing as argument 1,
But
right?
I'm
Or
calling it.
random or anything, right? This is just a placeholder. This means absolutely nothing when I'm defining the method. Inside here, self will actually be the instance. Oh,
Well, I'm just like, never mind. I'll ask later.
sure. I mean, that wasn't a bad question. So now I actually have access to the scroll object, right? And this scroll object has scroll methods on it. So can this scroll object from here make a nest?
Yes.
Yes.
Okay, cool. No, please, yeah. That's better than me dancing up there for like 4 seconds. It's like waiting. Yeah. All right, make nest. Build nest, sorry. All right. Cool. And so that's kind of like the idea that like you're out of string land and you're in this object land because you want to have access to all these object methods when you're inside each additional object. And it gets real nested in there. Nobody laughed? It's okay. It's rough.
So, you made the combo file that combines them all. Do you require combo
No. So that's a very good question. In here, I don't actually use require combo. I'm just building the file, right? And inside of combo.rb, all I'm doing is pulling all of those files into this one, and I'm simply running this file. So when I run this file, right, the exact equivalent is if I copied this and like this, so class squirrel, and instead of squirrel here, and I commented it out, I'm doing what is equivalent to this, but for all three. Oh yeah, that's why I'm trying to show you like all this, so that like when you're working on the subway, because you don't need internet for this, right? You're working on the subway, everyone's like, oh my god, hacker man, you've got all these like terminals up and code's just running through. You're like, I'm in. You're like, what? Okay. So, great.
Term saver.
So we have access to it here, right? The problem is, what happens when I exit this price session? Do I still have S1, T1, and this nest? No, like all of my test data is gone because it's in this one price session. And so that's kind of stinko malinko, right?
Could you save it from there, like with a dot save?
No. So what I want to do is actually, I want to like keep all of this test data. I want to make all this seed data. And so I could just do S1 is equal to squirrel.new. So I don't have to go inside the pry and do it. Oh my god. I have to create a better model. I like squirrels nested trees, I just have to be able to spell it. The idea here is that I want to create all this so every time I hit the pry, I don't have to make it every single time because that'd be so painful. If I make it here and then I hit the pry, the test data will always be there. So for me to be able to test. Yeah? So let's do it. What does the squirrel need again? Name and color? Cool. I'll help you out here. So Alvin, right? Red. We have Simon, who's blue. I do. Thank you. Get lazy sometimes. And then lastly, we have our boy, and that's green. If you you don't know what they are, that's okay. I'm a weirdo. Cool. Does anyone have any like favorite trees they like? Particular size? Ficus? A succulent?
Sequoia.
Bonsai? What?
Oh, that's right still. I like willow.
Banyan.
What other? I don't know.
Banyan.
We're just getting to know each other. Banyan? Is that a real tree?
It's like a tree in Florida.
It's a tree in Florida?
It's like really big. Like,
Spell that?
Banyon.
Banyan?
No.
It's like onion, but a tree.
I refer to it as like
Okay.
seed banyan.
This is a Florida-sized tree, just like there are Florida-sized things, like Texas-sized things. All right, let's just do one more tree for funsies. Oh, okay, classic. And how big is this maple tree?
Gargantuan.
It's a what?
Gargantuan.
Gargantuan? Oh man, people don't understand like the absolute pleasure you have with coding, like just nonsense. I remember when I was like learning a few years ago, and I would like explain to like my friends and family like what I was doing. It would sound a lot like this. You don't understand, man. We're making squirrels nest of trees left and right. Everybody gets a tree. It was amazing. And they're like, wow, Evans, that sounds exciting. Thank you, but no thanks. And I was like, come on, man, you should try coding. I don't know, man. It's hard sell. So, what does this nest need? Squirrel, tree, and waterproof, right? So let's just get crazy, right? Which squirrel should be in this tree? S1, 2, or 3? Okay. I don't get that reference, but I usually get all the dumb Shrek references, so I apologize to you. Dang, I feel bad. I feel inadequate. So what kind of tree is old Theodore in? The bonsai, the banyan, or the maple?
The maple.
Classic. And is it waterproof? Wow. Yeah. He definitely has a waterproof one?
Oh, yeah, he's smart.
Sure. I like how into the seed data we are in. All right, and then what about this, right? What about this new one? Who we got here? Simon?
Yeah.
Sure. What tree? I think Simon's the one with the glasses, yeah. That, you know, it's not important. What we're going to do is we're going to just do this. We're just going to knock out a lot of these nests because it's important. And then we're just going to go 1, 1, 1, 2, 2, 2, 3, 3, 3. And then we'll go for fun 1, 1, 1, 1, 1, 1, 1, 1. Didn't think I'd do it, huh? You know, you ever take that test? I'm like a professor on the side. And one time I made a quiz where everything was B. 20 questions, multiple choice.
How would you do that? It's torture.
That's just me.
Yeah, because it's a psychological trap. Like, ooh, B again? But anyways, there's a reason for this, right? That I actually needed to be like this. And hopefully it'll make sense. The idea here is we can actually see the seed data and check out these trees. Does tree 2 have any squirrels in them? No, but tree 3 has how many? 3, right? And tree 1 has like a lot, right? So let's just do this. In order to like establish these relationships, the idea is that each one of these classes should know about the other in some sort of relationship. So if I'm a tree, I should know which squirrels are in my tree, right? That just makes sense. So let's figure out how to do that. I'm in this tree, boop, 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 and I need to make a method that says which squirrels, okay, 2 R's, dang it, I mean, oops-a-daisy, positive attitude, which squirrels are in, oh God, I was going to say something that is kind of dicey, are in this tree. I was just going to say like this, which squirrels are in me, which I was like, I don't really know what, I mean, this, you know, it's what I mean, but you know what I mean. Welcome to Mod 1. So, What do we want to name this method here? No, let's not name it that. Let's stay away from that. I realize it's being recorded.
My squirrels.
Sure, my squirrels, right? How family friendly. All right, cool. So here's where the dicey logic kind of comes in, right? And like the big thing that I really want to focus on. And again, it's not about memorization. It's really got like, let's think this through, right? So I'm trying to figure out which squirrels are in my tree. Well, what piece of information do I know? Need to know. Do I need to know about the nests right now?
Because trees only be connecting trees and squirrels is next.
Yeah, all right.
Oh,
Like they're all in
Say again?
all of the nests are in
All the
Oh,
nests
yeah.
are empty.
Yeah, like
And two.
and two.
Yeah, but it doesn't really matter.
One and
Oh, yeah. I could change that, sorry. Boop, boop, boop. Boop, 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 boop. Boop. Ah. Yeah, I just got lazy. I thought that was kind of cool. My idea of cool is real low. So anyways, we're in, which squirrels are in this tree? So should we be looking at all the trees, all the squirrels, or all the nests? It should be nest because
That's the thing where you have to figure out where you're exposed to squirrels. That's why like you go through that to figure out.
absolutely the correct answer should be this like nest, because if I'm like in this tree and I'm trying to figure out which squirrels are inside this particular tree that I'm talking about, either tree 1 or tree 2, which of these three models knows about both? Has to be the nests, right? It's got to be the nests. So which one knows about both the trees and the nests? So what do I do here? I want to go through all the nests, and I want to do what? Sure, I can select them. Okay, and what am I doing when I select? What am I going through? What are each one of these? X, KV?
And
Just messing with you guys. Okay, so it's a nest, right? And what am I doing with the nest? I'm checking, right? But what am I checking? Like, I'm checking. Right, let's do this.
that's not, what are the members of the
Right, see, it's kind of like there's some idea, but it'd be so much easier and useful like once you're in here and you can see the data that you have. So I'm in the tree. Okay, just kidding. So boop, let's run this combo again. It's the tree class that has this my squirrels method on it. So what I really want to do is like pick on one of these trees and try running my squirrels so that I can execute this line of code so I can hit the binding. So tree 1, sure. Tree 1 dot my squirrels. And here I am, I'm in the binding. So what is this nest? What is the first nest?
Oh yeah, we made a bunch.
We made a bunch, remember? Remember where the binding is and what file I ran. It has all this seed data in it. No. Right, and this is why this is useful, right? So now I have this nest in here because it's gonna go through every single one of these nests. So I'm trying to figure out what information. I'm trying to figure out if this particular nest, what? What about it? Right, like if the nest, I don't know, if this nest and the tree that's in it is what? Is equal to self? Who would like follow that logic? It's kind of like a large leap. Well, let's think it through, right? I'm a tree. I'm tree 1 in this particular example, right? And it's the bonsai. So I'm going to go through all these nests, and I'm going to be like, hey, first of all, I need to figure out something, and that is I need a collection from all the nests where I'm the tree. And then in that collection, I need to look at all the squirrels. So far, so good. And so you kind of like, it's everywhere at once, but just that process, just thinking through. So I'm checking, really, of all the nests, which ones do I really care about? Do I care about, while I'm tree 1, do I really care about any other nests in tree 2 or 3 or 4? No. So I'm like, I'm checking the ones where what? I'm the tree. Cool? So, and the way to do that, we kind of talked about it, is I look at the nest, I look at the tree, and is it me? Right? So really, this is actually nests where I'm the tree. I'm going to make a variable here, and when I select it, it should return all the nests where I'm the tree. So far, so good. So now, if I were to do something like this, how can I test it? What would make sense to test? Where would I put a binding to kind of test this?
After the
What?
finding after the end state,
So what line would you put that on?
26.
Okay, 26. Where would you want to put it?
Yeah, either in between 20 and 25.
If we put the binding here, this will stop the iteration, right? If we put it here, this would be after the iteration, and then I can essentially check to see what this variable is. If I put it here, then it never ran, it's simply in the method and hasn't done anything yet, right? Those are kind of like my choices.
Or we could leave it where it is and call my squirrels. You get a whole result.
This is what I want to do, right? We already had a binding in here, and we kind of tested out what we were kind of looking for. And we've identified that we should check to see if the tree is equal to me. And so let's actually test to see if that logic works. So I'm going to put a binding here. So I have two choices from here, right? From 28, if I hit the binding, the first thing I'm going to check is, what does this variable return me? If it is what I think it is, then I know that this works. If it's not, that gives me a clue, and then I'm going to move the binding in and then test it again to see where it went wrong. Is that fair? And so for me, I want to test it here, investigate. If it's good, I can move forward. If not, then I know where to step back and go deeper and deeper and deeper. Cool? Okay. So let's do this. Oh. So when you're in iteration, every time you hit exit, it hits the next one, right? So like if I were to go, what is the nest now? Notice that it's like this one. If I hit exit and I check the nest again, it's the next nest in the iteration. If I want to break out of the whole thing, I can either double bang it, right? 2 exclamation marks, or I can exit with a bang. It'll just break out the whole thing. Okay? Okay. I know I ask a lot of questions, and sometimes it's really hard when I'm like actually looking for a response, and it's all like, all right, so let's try. Ready? I'm going to take a look at this, this tree 1, and I'm going to invoke my squirrels. Cool. If I do that, I get stuck in the binding. And let's think through here. Nests where I'm the tree. Remember, I called it on which tree? T1, T2, T3. T1. So if I even look at my test data, if I go through all the nests where I'm the tree, how many should I see? 7, right? That's the idea. I need to test to see if this method's working. So if I were to do that, if I were to see what are nests where I'm I'm the tree. I see 7. That is correct. So far so good. I can exit out. I can exit out of here. If I try it again, right, and notice T2 has how many nests? 0, right? So in theory, if I do T2, which is the second tree, dot my squirrels, if I were to check nests where on the tree, what should I see? So I've just proven to myself that this works. This is how I self-tested. This is very important. Because again, as you're being assessed, as you're writing code, as you're moving through, especially not to focus on the code challenge, but just as like a metaphor, there will be no tests, there's no RSpec on it. So when you write code, you should be able to, in your mind, understand what you're evaluating. And by simply looking at your own test data, writing some code, executing it, it should make sense and it should be what you want it to be. If not, then go back into your logic and then move that binding around appropriately to dig into where you need to be. Yeah?
Why is that nest from the tree returning
I'm sorry, one more time?
Sorry, why is that nest where on the tree returning an empty array?
Awesome. And then I'll get to your question. So remember, the first thing I did, I tested T1. And then I said my squirrels, which invokes this method. Right? And when I did that and I tested this variable, nests were on the tree, if we counted all the nests.new, where T1 is the tree, there are 7 there. So we got 7, that made sense, right? And so in theory, if I tested the exact same method, calling it on T2, and I invoked my squirrels, the instance method, on the instance of T2, and I look through all the nests, which is what this is doing, nest.allSelect, and I'm saying, hey, if the nest.tree is equal to self, then select it. Looking at the test data, are there any nests where T2 is the tree? No. So that's why I came back as an empty array. What's your question?
Yeah, so I feel like I'm becoming pretty reliant on the tests, like just basically it's just like learn dash that do what it tells me to do. Are we gonna have like much of an opportunity before the coding challenge to like work on testing our own code?
This is exactly how to test your own code, which is why I'm going at a very fast pace through this. The idea is that like you should be able to write methods and then test them. So we started this whole thing with the deliverable. And that is a tree should be able to see all of its squirrels. That would literally be the deliverable like on a code challenge. You'll have maybe this tree class half built.
Right.
And then it'll say, please write a method that has trees can see their squirrels. And that would be it. There's no RSpec. And so when you submit your code, you should have tested it, make sure it works.
When are you gonna get practice? Like, 'cause right now, like the tests, like I guess we could do it on our own, but the tests kind of like encourage, like don't really require that. Like,
Oh, okay.
So like, when are we gonna get a good time to practice?
All right, so nests were on the tree. It makes total sense that if I'm calling it on tree number 2, that it should be empty, right? That's like kind of where we left off. So I've tested on my own without the magic help or reliance of RSpec, and I've proven that it's delivering what I want it to deliver. So what if, right, in this next sort of part of this deliverable is instead of essentially seeing all the nests in my tree, because that's what this is giving me, I actually want the squirrel objects. I want to see the squirrels that are in my tree, not just a list of nests. So far, so good. Because right now, remember, it's an empty array, but when I called it on T1, what did I get back? 7 instances of what? Of nest. Is that actually meet the deliverable that I'm looking for when I'm like, I want to know the squirrels that are in my tree, not necessarily the fact that I have 7 nests. I want each of these squirrel names, exactly. I want each of these squirrels' names, not just, hey, wonder what squirrels are in my tree. Bro, you got 7 nests. That's not exactly what I asked for, but all right, cool, thank you. And so now we got to take this one step further. So the first thing we needed to build was the fact that I knew I didn't care about, when I looked at all the nests, if it was a different tree. I can isolate the fact that I'm the tree that's involved in this nest. And now I need to look through all of the nests where I'm the tree and ask for the squirrel. Right? I need to look through all the nests where I'm the tree and say, what's the squirrel in that tree? What's the squirrel in that tree? What's the squirrel in that tree? So if we were to actually go through it, eventually when I go T1.mySquirrels and I see nests where I'm a tree, I'm going to go in this first one, I'm going to go through each one and go, great, what's the squirrel though? What's the squirrel though? What's the squirrel though? And so what data type is this that's coming back? An array. So that means that nests where I'm the tree is an array. And I want to go through all the nests where I'm the tree, and I want the squirrel name. So I can do something like each, because remember it's an array, so it has the each methods. Do. And what are these inside this? Are they trees?
Squirrels.
Are they squirrels?
Oh, nests, yes.
They're nests, right? Interesting. Okay, so now that I'm going through them, right? What do I actually want in here? I want inside the nest, what is this squirrel? Do I want the squirrel object? I just want the name, right? Just want the name. So let's test this. In theory, right, this is like squirrel, 2 R's, 1 L, names. This is what this should be, right? Why no? What does each return? What does each give me back when I run it?
The original.
The original array, right? What I really want to do is take this nest array, these 7 nests, and I want to transform them into names. I want to transform it from these nest objects into a string. And so which one of the iterators is best for doing this one-for-one transformation? I saw a lot of weird responses to that. So remember, if we were to do string A, B, and C, and I were to do a dot each do, and what are these? It's like letters? Sure. Oh yeah, it's letter. It should be letter, right? It should be letter, but whatever. So dot letters, I don't know. Can we concatenate strings? Right? 1, 2, 3. End. What did it return me? The original array. If I were to do the exact same thing, and instead of each, I used map, and I'm going to use letter this time, and I do letter, I don't know, plus 1, 2, 3. It transformed it. Yes, you can use collect. Map and collect are exactly the same. Map and collect are exactly the same. If I were to tell you which one to fall in love with, I would say use map, because map is more universal to other programming languages. So if you just get used to using map in Ruby, and you see map in JavaScript, you see map in Python, then you'll be like, oh, okay, I know what map does. If you fall in love with the word collect in Ruby, then you'll have to go, oh, JavaScript map is that. And so that can be a little bit of a leap. So that would be the only reason why I recommend one over the other. All right, so if, what? If, you got a question? For sure. If I were to now test this in theory, I should see squirrel names because I've transformed this array of nest objects. I've mapped over them one for one, and what I want to get back is in each of the nests, the squirrel dot name. So I can test it by simply getting out of here, running my combo file again, and on T2, right? Actually, T2 has no nests, right? That would be crazy. Let's just use T3. T3, right, has squirrel 3, 2, and 1 in there. And squirrel 3, 2, 1 is Theo, Simon, and Alvin. So in theory, if I run this and I check squirrel names, what should I see? I should see Theo, Simon, and Alvin, right? That as strings. So let's do that. T, 3 dot my squirrels. I'm in the binding. So what are the squirrel names? Why am I not testing nests where I'm the tree?
Well, let's not keep the thing.
Because I tested it already and I made no change to the code. So I can assume that that's not where the problem is. Right? And there it is. Are there any questions as to why we used map and not each? Who feels like map was the right choice? Who knows to choose map when they have to do something like this? Okay, that's the goal. Noise? Yeah.
So a common mistake that I sometimes make is I would select thinking that I should be returning back a reduced array of specific names.
A reduced array of what?
Like select, you know how it returns back a smaller number of whatever you're asking for since it selects
Yes.
particularly for that condition.
Correct.
In this case, we wouldn't use select at all, even though we're just trying to return back names.
Yes, remember select, right, takes a condition. And that sometimes will shrink the array. Here, I already have everything I want, but instead of these nest objects, right, I get 7 of them or I get 3 of them, and I want to do a one-for-one transformation. So I'm picking the right iterator for the job. Short answer, no, I would not use select for this case. But yeah. All right, cool. So let's do a little bit of what is known as refactoring. The idea here is that this my squirrel is doing 2 main functions here. The first is actually going through all the nests, making sure I'm the tree. And then the second one is once I have all those nests, now I'm actually transforming them into squirrel names. There is like a principle in programming that each one of your methods, each one of your functions should only do one thing. And that way you're not writing one method that's like 20 lines long that does like a million things. And so what we can do is like this is a piece of functionality and this is a piece of functionality. So what I can do is I can simply make a new method. And the first thing is all it's doing is it's going through all the nests and seeing which one am I the tree in. Right? So what would you want to call this method?
My nests.
Sure, my nests, that makes sense. So my nests. And all it does is this. Bloop. I'm going to get rid of this variable because I don't need it. And now I have a method called my nests. So really, what is this? Nests where I'm the tree. Do I have a helper method, a method that I just built that can do this for me? Right. So I would just do my nest.map. And if you write your methods well in the way that you name them, it will read very, very easily. And that is this. Check it out, my nests. I'm going to go through all the nests where I select for each nest, where in that nest, the tree in that nest is me. Oh my God, that makes so much sense. Right? The pseudocode directly translated into the actual code. So if I'm looking at my squirrels, what I'm really trying to do is go through all of my nests, transform them into squirrel names. And that's really what's happening here. So I can get rid of the binding. I also don't need this extra variable. Boop, boop. And so that's the final product. Right? So this is like a helper method because I'm going to use it in another method. Are there any sort of initial questions about how we went through that transformation? That one big method and then broke it down into two separate methods so that each method does one thing. All right, hey, it's been like over an hour. Let's take a quick 5-minute break. Yeah. All right, so now, right, because we actually extracted this like my nests functionality instead of keeping them all in this my squirrel, right? What did I call or describe this method? What was it? Because I've used it in another method. Like a helper method, right? So let's actually see how helpful it can be. What if one of the deliverables was something like, great, a tree should be able to know how many nests are in that tree, which is like a logical thing to sort of ask, right? In this sort of like Pocahontas-like world, right? So how many nests do I have? So what would you want to call this? Right, num nests, like nest count, something like that. So num nests. And then how would I do that? What information do I actually need? Right. So what I really need to do at some point, again, need to know all the nests where I'm actually the tree. The thing is, I've already built some sort of helper method that can determine that. So this method's super easy, and I can just simply do my nests, which is all the nests that I'm the tree, and it returns an array, and I can just call .length on it. And so this is how you can reuse my nests like in two different scenarios. All right, so this helper method's very useful. Cool? Any questions on this? Nothing crazy, right? All right, so let's just do one more thing in here. And that is like, I need to be able to call a method, right, that grows the tree. It just grows the tree. So, man. Oh man, this would be interesting. So, let's do this, right? Instead of size being like a string, let's just make it a number, right? So, size, you have 1, 2, I know, I'm gonna miss gargantuan, 5. Cool? It's kind of big, no big deal. It's just a gargantuan tree. Oh man, I need to get rid of this too. Sorry. It was just a silly example. All right, so this deliverable is basically, I need to be able to grow this tree. God bless you. This tree needs to be able to grow in size, right? So tree needs to grow. What do you want to call this method? And should it be a class or instance method? Should the class know about each individual tree's growing, or should the individual tree know about it growing? The individual, right? So should this be a class or an instance method? Right. So what do you want to call this method? Sure, grow sounds fine, or like water. Let's call it water. Cool. And what should this do? Right? It should just be like the size should just probably grow by 1 or something. And so how can we test this? What the? It's weird. How can we test this? Well, if I do the combo, I can take a tree. I'm going to do, size 5. I can do dot water. I'm going to water that tree. And I can see T3 again. Look at that. It grew. So powerful. So one of the things is, yeah?
Can you just explain why it has to be an instance method, not a class?
Sure. So remember, right, the deliverable is that the tree needs to be able to grow, right? I want to increase the size by 1 every time I call this method. So when you're determining whether or not it's a class or an instance, you have to think through, should all of the trees be aware of each individual tree growing, or should the individual tree instance care or know about whether or not that individual tree instance grows? Right, so if it's an individual on an individual instance, it should probably be what type of method? Instance or class?
If you kept on running T3.water, would it keep on incrementing the size, or would it just stay?
It would increment forever and ever, right? And if we wanted to prevent that, you had a question?
Yeah, I was gonna say, will it work if you use self-dot size plus equal 1?
Yeah, this should also work. Because you're referring to the instance, and you're checking that size, and you're adding 1 to it.
All we do is we have the access.
Yeah, right? If you do self.size, right, this will work because you have this here. Because remember, you're calling dot size on the instance, right? Whereas here, you're accessing the instance variable property of that tree within the class. So for all intents and purposes, sorry if that was confusing, they work the same for what you need to know.
So if you wanted to water all the trees, like do that to like every single tree, how would you set it?
Cool. That's an interesting deliverable. Let's do that, right? The deliverable like water all the trees, right? That's what you want to do. So now you want to water all the trees. Should the individual tree instances be aware of this, or should all the trees sort of like have a stake in this? Okay, so should this be an instance or a class method? Great. So I'm going to define a class method. Right? And how do I do that? Right? Self.water. And that's okay, we could do that because this is an instance and this is a class method. They should not be interfering with each other because of how you're going to call them. Think about it. The instance is going to be tree.t1.water and the class method is going to be tree.water, and they should not be clashing because of how you're going to invoke them. So you can have the same class and instance methods be named the same if you wanted to. Cool? So that being said, what should be happening here? What's the logic? If I want to water all the trees, you get some water, you get some water. Cool, what is add at all?
The array of all.
Right, so first of all, it makes sense that I need access to all the trees, right? That's easy. So I'm going to do something. I don't know what it is yet, right? So for now, I'm just going to maybe do like a dot each. If I don't know what iterator I need to pick, I'm just going to default to dot each until I can determine possibly, maybe, if there's a better iterator. So I'm going to simply do dot each do. And what are these? Squirrels? And then what needs to happen? Each one of the trees, the size, needs to do what?
But the button,
What you would have to
Well, let's think, right? Let's check it out. We're not sure, but we've actually assumed the logic and we've wrote it. So we should probably do what now? Test, right? So let's do it. Boop, boop, boop. I can do tree.all, and I see I have 3 trees, right? Size 1, 2, and 5. I could take T1, which I know is size 1, T1.water. That will increase T1 size to what? So if I do tree.all again, what should I see? 2, 2, and 5. If I do the class method.water, what should I get? So, do I need to change the iterator from each to something else? No, I think it's totally fine because I'm just going to do something to each item and then I'm going to go away and disappear. I don't need to like find a particular one. I don't need to select a certain one. I'm not transforming that data into anything. I just need to actually go through all of them, boop, shoot a little bit of that water action, and then roll out. What's interesting is, remember, tree.size plus equals to 1. Am I doing that anywhere else?
Yeah, I was gonna ask about that.
So on this individual tree, can I just water it?
Would you rename your class method to like water underscore all or something? That's a good idea.
Would I rename this water all?
Just so it doesn't look weird.
Personally, probably not, but you can if you want to. Again, this is like a dealer's choice what you want to name things. For me, I know that this is the class method that does water, which is going to increase the size of everything. And if I look at the instance method equivalent, it increases the size of the one thing. So if I do tree.water or instance of tree.water, I have an idea of what's happening. So, with that being said, it's been an hour and a half, right? And I know for a fact that all of you are extremely engaged and you want me to lecture for another hour and a half, but I'm going to let you down. And so if there are no particular questions as to the difference between an instance method, a class method, how we can determine whether or not it should be an instance, whether or not it should be a class, kind of thinking through deliverables, right? Building it first and then possibly refactoring if I need to so that each one of my methods does one thing. And then seeing how, even though I'm in the tree class, I still am using and referencing other classes, right? What I want to leave you with is if I were to give you a list of deliverables and it said something like, the squirrel should be able to see all the trees that the squirrel has a nest in, who feels comfortable being like, you know what, I can figure out how to write that. Right? Like you don't have to know it off the top of your head, but if that was a deliverable given to you today, would you feel like, you know what, I understand what it's asking for, and I know what I need to do. Not that I can type it from memory or that, boom, I'm just going to copy and paste it. It's like, I can logic my way through this. All right, cool. That's really all I have for you in terms of like many-to-many. The idea is that many-to-many has a join, and in that join, it's always going to be a has many belongs to, and another has many belongs to. Cool? All right, that's all I have for you.